Okay, so example 16, we need to evaluate whether or not we have the ability to get concentration or are we just given pressures. In this problem, I have mass and I have volume, so I can get concentration. This problem has a couple extra steps in it. So be aware of what kind of units you have. Normally, I've been given you, or you were given, moles and volume. This time you're given mass, but we can get to moles from mass if we know the mass and what the substance is using a periodic table. So we know we need to have N2 at some point, H2's concentration, and NH3's concentration. Now, we could be given concentrations at the initial position or the equilibrium position, but we have to have something for each, whether it be an I or an E. Okay, so we're going to go through and calculate the molarity of these. So we're going to take 15.25 grams of N2, and we know from the periodic table there are 28.02 grams of N2 for every 1 mole of N2. So if I take 15.25 and I divide by 28.02, I'm going to get, with 4 sig figs, 0.5443 moles. I'm going to divide by the volume, 4.528 liters, and we're going to get an answer here, 0.5443. I'm going back in and putting these numbers back in, so if you're doing it with me and you're not clearing your calculator out, you might get slightly different values based on how we are going to be rounding. Okay, so that's the concentration for that one. I am going to move these down just for space, so pardon my fixing here. And then give myself some space. There we go. H2, we know its mass is 10.25 grams of H2. And we know from the periodic table there are 2.02 grams of H2 for every 1 mole of H2. So this is going to be then, let me just do a little cleaning up here for space. This is going to be 10.25 divide 2.02, and I'm going to get 5.074 moles, about divide by the volume, 4.528 liters, because we need concentration. So 5.074 divided by 4.528, and we are going to get 1.121 big M with rounding. And then we can also try to get a concentration for NH3. And I see that I have 12.53 grams of NH3. And I know 1 nitrogen and 3 hydrogen. Remember how to do that. If you don't, I would suggest you email me so we can practice together. This is just the periodic table number. Okay, so I took 1 nitrogen at 1401 and 3 hydrogens at 303, and I got 1704. That's a 4, not a 9. So 12.53 divided by 17.04 is going to give me moles of 0.7353 moles divided by the mass, 4.528 liters. So when I do that, 0.7353 divided by 4.528, I get a concentration for this guy to be 0.1624 big M. Give me just a second. I want to check those numbers against my answer key instead of you listening to me check them. Okay, back with you. Those numbers look good compared to what I did the first time I did it. Okay, so now we have to evaluate, are these concentrations at the initial position or the equilibrium position? So we got to go back up here and read these. Remember that we don't care about this because it's a temperature. And right now we don't need to worry about that. So what we're going to do is we're going to read this, and it tells us that doesn't tell us this is equilibrium, so we assume it's initial. Doesn't tell us this is at equilibrium, so we assume it's initial. It does tell us that this is at equilibrium. What is equilibrium? So it says right here, at equilibrium, so we know this guy is at equilibrium, assuming the rest aren't. So we're going to need an ice chart because we have to have everything at equilibrium, otherwise we need an ice chart. N2 plus 3 H2s goes to 2 NH3. We're going to do our ice chart. We know this is 0.1202. This one is 1.121. And we don't know this initial amount. We do know its E amount, which was, I can't see it, so give me a second, 0.1624. So this is 0.1624. This is going to be a number that you're going to plug into your expression in just a moment. Well, maybe not just a moment, but in a little bit. Okay, so we have to figure out the C, which is the change portion. Remember that in order for this to go back and forth, back and forth, back and forth, to equilibrium, reach equilibrium, we have to have something being created and then breaking back apart or whatever. So this, because we have a 0 on this side, that indicates that this is the plus x side, specifically plus 2x. Why plus 2x? Because first of all, it's plus because it has to increase on this side. That's what I mean by plus, in order for it to shift back to that side. So I have to make some of this before I can break it down and make those back and forth equilibrium. The 2 comes from the fact there's a 2 in front. So once I know this side is the plus side, then I know this is negative x and this is negative 3x. So I now can figure out that this E is 0.1202 minus x. And I'm just going to kind of do this to help separate these. This is 1.121 minus 3x, and this is 0 plus 2x. So remember that your E is always I plus C. So I have an I plus C, which means I can solve for x. Now, it's very important that if you have an equilibrium value, I would circle it like I did here, because that's the value you're going to be plugging in to your K expression, not this x value, because x doesn't represent the equilibrium of NH3. 1.1624 represents the equilibrium value of NH3. X represents itself, x. So I can solve this now by taking 0.1624 and divide that by 2. And I get my x to be 0.0812. So therefore, I can plug that into up here. So now 0.1202 minus 0.0812 and 1.21. Let me try that again. Let me fix that. I misspoke there. I miswrote and misspoke. Okay, so this is going to be 1.121 minus 3 times 0.0812. Okay, so 0.1202 minus 0.0812, and I get 0.0390. And then 1.121 minus 3 times 0.0812, and I get 0.877 here. So now this is my equilibrium value for this one, and this is my equilibrium for this one. Now I have 3 equilibrium values. Again, I want to repeat that this is my equilibrium value that I calculated over here for NH3, not X. X just helps us get the other equilibriums. So K will be NH3 squared over N2 times H2 cubed. Now we're going to plug those values in. I believe this question asked us to figure out the equilibrium constant. It did. That's what we're doing here. So we're going to do 0.1624 squared over 0.0390 and 0.877 cubed. I'm looking at this up here. I'm going to put my equal sign over here because that looked a little weird when I looked up and I don't want you all confused. So this is the work I did for up there. Okay, so when I do that, I will get 0.1624 and square that on my calculator, divided by 0.0390, divide by 0.877. This is a 7 right here. Divide by 0.877 and divide by 0.877. Now you can cube that and divide it. I just don't like to take the time to do that. I get 1.00 for my value. And that concludes our number 16. I want to come back and just say that this would be k equals, obviously. So that is the answer that they asked us to solve for.